The key thing for 6.3 in the linear programming is that you're able to find points, number one, and number two is that you're able to put those points into the objective quantity, right? So, we started with substitution. Substitution works really nice for equations that have vertical or horizontal lines, right? Because they're already solved for x or they're already solved for y, right? You just take whatever x is equal to and substitute it in for the other equation, solve for the opposite thing, right? So substitution really worked great for all your x is equal to or your y is equal to, because it's already solved for x to substitute in. But if you're given equations that have x and y in a number, you can still use substitution. Like here, I took the first equation, solved for a single x, and substituted that in for y, or for x, and solved for y, right? We did this example yesterday. But then we talked about the last way you could do it, which was elimination. In elimination, you had to line up all your x's, all your y's is equal to all your numbers, right? And then we lucked out here because our y was opposite of each other, right? So we could put a plus sign. What would you do if it wasn't a positive 1 and a negative 1, or a positive 1 and a positive 1? Okay? What if it was just like 3 and 5? What would you have to do? We don't subtract, we don't move them. We multiply each equation so we get the same number. Okay? So I could do this whole thing over again via elimination with the x's. Do you want me to show you just elimination with the x's? Okay. You have to have a common term. So I'm just going to do some erasing. And so that point was 6, 4, right? So you guys have that written down. It's up to you if you want to write this down or not. What you do if you don't have common ones, so I'm going to try and make the x's common. We're still going to end up with the same point, just a different way to skin the cat, right? So 3 and 5, what's the lowest common multiple? It's the same, Kelly. Skin the cat. Okay, good. So lowest common multiple is 15, so I'm going to multiply this top equation by 5 and this bottom equation by 3. Why? Because 3 times 5 will give me 15x, and 5 times 3 will give me 15x as well. Okay? So in this case, 5 times 3 is 15x. 5 times negative 1 is negative 5y. And 5 times 14 is 70. So it's equal to 70. Okay, so that's that top equation. So I'm just doing this question, the last question from yesterday again. Right? So the second equation, 5x times 3 gives me 15x. 3 times y will give me plus 3y. And 3 times 34, that's 90 plus 12, 112? Oh, 102. You're right. Okay. So it's the same thing, except for now, instead of my y's being, oh, these are opposite, my x's are the exact same, right? So if my x's are the exact same, should I add them together to get rid of the x's? You can subtract them. So with elimination, you can either add or subtract. It depends on what the numbers are in front. So here, I'm going to use subtraction. Okay? So 15x minus 15x, no x's, right? Negative 5y minus 3y gives me negative 8y. 70 minus 102. So this is a big thing. You have to remember that this sign is here. So 70 minus 102 will give me negative 32. If I divide, do I divide? I'll be right there. Negative 8 divided by, no, negative 32 divided by 8 by negative 8 is positive 4. Okay. what do we do with this y value? Plug it into one of the equations. I would go up here and solve for x. Can I leave someone while I work with pre-calc? Karen, can I leave you up here to finish this question? Or should I finish? Okay, I'll finish. We can substitute y in, so we get 3x minus 4 equals 14. You add the 4, that'll give you 18, right? And you'll get 3x is equal to 18. So x equals 6. And so my point of intersection is 6, comma 4. Just like yesterday, same equations. Instead of subtracting the y's, I subtracted the x's, get you the same answer. Okay? Now, while I'm fixing this issue with pre-calc,
I'll go fetch those pre-calc 17.
you printed them. I printed them yesterday. They just never got stapled last night.
Oh, so I can hand these up? Cool.
Thanks. Sorry.
Sure.
What a bad recording today. Okay. I guess I can say that. So, we're going to put it all together. Finding the intersection points and solving for the maximum or minimum. In this question, it says find both max and min. Okay? So, just like the original question way up here, after the drawing we had the points. We put the points right into Q and solve for max or min. Okay. We're not given the points this time. We have to solve for the points and then substitute them into Q. So what do? Well, the first thing I would probably do is I would graph these things. Okay. Why? Because it's nice to see, and then you can see the graph. And usually most of my questions I will ask you to graph them first. So I'm going to take these equations. What did it say?
Yeah. You're on the wrong side of the paper.
Okay, thank you. So let's graph these. X is, does that say greater than or equal to 2? Now, when I got people's assignments, you know what was really nice? Some people labeled their lines by just putting a little nice little dot here. Just say, oh, the red line, that's where x equals, or x is greater than or equal to 2. Okay, so that's nice to do. Somehow you have to label them. Okay, some people will put a 1 and they'll put a 1 beside the line. Okay, that's how I expect you to label your lines. So x is greater than or equal to 2. Where's x equal to 2? Ooh. Right here, right? Or here. And so I draw a solid line because it's also equal to, and it says greater, right? So my little arrow will go this way. What? Okay. Now, the next one says y is greater than or equal to 4, right? So maybe this will be my black line. Y is greater than or equal to 4. And right here. And which way do I color? Okay. So right now, I have this little square in this top corner that I'm working with, right? Hopefully you're using a ruler and your pen aligns directly with your paper so you're not going to have the issues that I'm having, right? That third line, how do I graph that line? X plus y is less than or equal to 14. You can find the x and y intersects, right? So x to 0, y to 0, or you can do y equals mx plus b. That's what I'm going to do for this equation. I'm going to do y equals mx plus b. So I draw the green right beside it. I'm going to subtract the x, so I get y is equal to negative x plus 14. That means 14 is the y-intercept. I don't have a 14 on my page. I have, what, 9 or 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When this happens, you can either change your scale or you can go up 11, 12, 13, 14. So that's my point. And then I can go a slope of -1. So that's down 1 over 1. Or if I go down 1, 2, 3, 4, I have to go over 1, 2, 3, 4. Okay, so down 1, over 1, down 4, over 4, whatever you would like to do. We've got to draw that line in, right? Yes. If I say over, it means forward. If I say back, it means the opposite way. And it's still a solid line because of the fact that it's equal to. Okay? Which way do I color? Well, I should put 0 or 0 in or something. 0 plus 0 is less than 14. I agree. So I'm going to color downwards. So right now I have this triangle, especially if I extend this line. I have that triangle there, right? So I just have to graph that last one. 4x plus 3y is less than 48. So we can do two different ways. We can set x to 0, solve for y, set y to 0, solve for x. Okay? So if I set x to 0, I get 4. Before I really not blue one. Let's make this a blue one. I get 4 times 0 plus 3y is equal to 48. So that gives me 3y equals 48. Divide by 3. So y equals 13? No. 16, right? Is it 16? So that point is 0, 16. So that's 14. So 16 is even higher. Right? And I'm going to set y to 0. So I get 4x plus 3 times 0 equals 48. So 4x is equal to 48. Divide by 4, x equals 12. That's 12 comma 0. So when I put 12 comma 0, go out 1, 2. That's my last point. So 12 comma 0. I'm going to go up there. Use your ruler. Oh my gosh, that is horrible. Okay, but you use your ruler, you'll just point there. So now we have to decide which side are we coloring. If we put 0, 0 in, is 0 less than 48? Yes, right? So we color here. So it's this section here, all the way up. Okay, so there's about 4 points. Do you guys see the 4 points in your graph? I'm just going to pull up my highlighter here so you can see those points. Hopefully I can pull up a highlighter. So what I tend to do is I tend to try and highlight the points that I have. So I have this point right here. I have this point right here included.
Highlight all the points of the feasible region.
Highlight the points on the feasible region. This point. And then is it the green or the blue one that's the low point on the line?
They cross.
Do they cross right at the line?
Yeah, they look connected. Yeah, our lines are way different.
Well, it could be with my
My points are
non-ruler.
2 and 2 and 4 and 9 and 4.
So you have one that connects right at that line. Right? Is what you're telling me? Potential.
Yeah, we also have one that connects like right in the middle.
Oh, so this one's closer in the middle. That mine's drawn. But remember I said I use non-rulers on this thing, so it's going to be way off. Yours should be closer. yours should be closer to the ones you actually solve for.
Yeah.
Okay? But you still have 4 points, right? And so the next step, you guys, is to solve for these points. Some of them are very easy, okay? I always go with the easy points first. What's my easiest point? My easiest point is right here. Okay? Why? Because that's where x equals 2 and y equals 4. I have no solving for that. X equals 2, y equals 4 there. No solving at all. No substitution, no elimination. At this point here, x equals 2, y equals 4. There's no arguing with that. Right? This next one right here, where blue hits black, it could be slightly off, so we should check. And when it's a horizontal or vertical line, I go right into substitution. Okay? My black line, and this is where labeling is really important. What's my black line? Y equals 4, or y is greater than or less, or greater than or equal to 4. What's my blue line? The 4x plus 3y is less than or equal to 48. See how it's important to label and see which lines they are so you can know which intersections you're finding. Okay? So if I'm looking at this next point right here, it's where the black and the blue line hits, right? I'm going to do substitution. 4x plus 3, and then I'm going to substitute my y value of 4 here. Equals 48. So 4x plus 12 is equal to 48. Subtract 12, 4x is equal to 36. So that point is x is equal to 8. 36 divided by 4? Is that 9?
Yeah, it's 9.
Good. You see how my graph looks like 8, but I don't use rulers? Your graph probably looks closer to 9 because you use a
It's
ruler.
like 2.
Okay? Good. But the equation is telling us 9, right? So what is this point? 9 and 4, because the y value was 4 that we substituted in, and we saw for the x value of 9. Okay? Now, the next one I'm going to go up to is the one that's on this other vertical line, because those are the easy ones. Okay? What's the x value there? 2, right? Because that red line is this x is greater than 2, and it's dealing with the green line. Is that the one it's crossing? So we get x, which is 2, plus y is equal to 14. So we subtract our 2, so y is equal to 12 there. Okay? So what is this point right here? 2, 12. And you could tell me that by reading it off the graph. But if the question tells you you have to solve for the vertices, you actually have to show this portion of work. Okay? The last type, or the last point we have to solve for, mine's way out there, because I didn't use rulers on either line. Yours is a little bit more centered. This is my last point right here. It doesn't matter. You could go in a circle around this square. I could have had this one as my last point. I choose the hardest one to do last, but you could do them in any order, just so you know. So I choose both vertical and horizontal lines first, then I pick points that have a vertical or a horizontal line with it, and then I pick the ones with the 2 diagonals, because they're the more difficult ones to deal with. Yes, Dylan?
How did you know the 14 on that last one?
Because that's that green line that crosses there, right? So it depends on which line is there. And if you use a ruler, you'll have a better accurate picture of which line actually crosses there. Okay? So, can we talk about this last? They meet there. There is a 4th point, you guys. They meet there. If you don't have a 4th point, your graph is worse off than mine, so you might want to redraw it. Okay? There is a 4th point there. That point is between the green and blue line, so that's between x plus y equals 14, and between 4x plus 3y is equal to 48, right? Do you want to do substitution, or would you like to do elimination? I like elimination with these things. I don't know why, I just find it less work. But some people like substitution, and that's okay. I showed you how to do both ways, right? So, what I'm going to do is I'm going to multiply, let's get common x's. So I'm going to multiply this top one by 4, okay? So that'll give me 4x plus 4y is equal to 40 plus 16, 56, right? And so, I put it right underneath so it saved me a step from writing that equation again because I'm lazy. It's up to you how you do it. 4x and 4x, do I subtract them? Do I add them? So I subtract them. 4x minus 4x is nothing. 3y minus 4y, negative y. 48 minus 56 is negative 8. So I divide by negative 1. Y equals 8. What was our x value? We don't know yet, do we? You can read off your graph, but you can't be for sure, right? So this is why it's nice not to do it all around the graph, that you do it on a side paper or whatever, so do it on your loose leaf. I'm just going to erase this other point's work. And I'm going to add in here, okay? So, I know y equals 8. How do I solve for x? I put it into one of the first equations, so x plus, instead of y, I'm going to substitute a. It is equal to 14. I subtract 8, I get x equals 6. Just like you guys were telling me from your beautiful graphs that it was 6, 8. Okay? So we use 6, 8 as our point. Are we done? We have to find the maximum and the minimum. So we have to take these points. Okay? So I'm going to go back here. You guys are going to tell me the points. What were the points? The points were 2 and 12, 2 and 4, 9 and 4, and 6 and 8. Okay? If I was looking for just the maximum, well, I wouldn't look at 2 and 4, right? Because I have one that says 2 and 12, and I have one that says 9 and 4. So if I was just looking for the maximum, I wouldn't even do the work for 2 and 4. Okay? But we're looking for max and min, so we should do the equation. They'll give you a Q equation, or eventually, you guys, we're going to make our Q equations. Okay? Eventually, we're going to get there and make our Q equations. So we plug in what we know. 10 times 2 is 20 plus 15 times 12 equals 200. Okay. 10 times 2 plus 4 times 12 equals 80. 10 times 9 plus 4 times, plus 15. Whoa, what am I doing? 10 times 2 plus 15 times 4. 10 times 9 plus 15 times 4. So equals 150. And then the last one, 10 times 6 plus 15 times 8 equals 180. So, from that, we can find the max and the min. There's a max at 2, 12, and it's 200. And there's a minimum at 2, 4, and it is 80. Okay? So these questions are long, and we haven't done all the parts to them yet, right? We just graph the constraints, come up with the points, and solve for max and min. Okay? Eventually, like the next part of this week, we're going to talk about how you come up with the constraints, how you come up with the objective quantity in word problems. But today, we're not there. Today, what do we have to do? Graph the inequalities, find the points, and determine whether you have a max or a min at certain things. Okay? So, this last example is your first question, and I've got 2 more printing off from you because your textbook isn't following what I want to teach. Okay? Sorry.
That's